Good day once again, my viewers. You are welcome back to class. Like I said in the previous video, many of you have been asking me to carry out some calculations on titration using some examples from the past question. We indeed did one the other time. We are going to go into another one. Like I promised you, I'll be doing many and many. The essence of these titrations we are going to be doing is for you to get acquainted with the pattern they normally use, because just they alter one or two part of the questions. The same pattern remain the same pattern. For example, from that table you are going to draw to the average volume of acid you are using is usually 11 marks. The many marks you are going to contest for, apart from that, is just 9 marks. So the pattern is always the same. So by the time you continue to watch my video on and on and on, often and often, most of the questions they may even bring, especially this coming WAEC SSC practical, you may be surprised that we have already tackled it. So based on that, let's see how let's handle this next calculation. This one occurred in 1999, but it's still the same thing, the same question they always bring. A is a solution containing 3.70 gram per dn cube of an acid HS. The name of the acid is not known. B contains 2.15 gram of sodium hydroxide per 250 cm cube. Like I told you the other day, most students, when they see this one, they know it's not standardized. To standardize it, you get your 2 marks. Put it into the burette and titrate it against 20 or 25 cm cube portion of using methyl orange as indicator. Record the volume of your pipette, tabulate your burette reading, and calculate the average volume of acid used. So let's start with that. First of all, to carry out this, you say volume of pipette 25.00 cm cube. That's the one we used in my school. Let's share the table. So you have here titer values or titration table. You have the first one. Always make do with 3. Rough cm cube. First cm cube. This unit is very, very important. Second cm cube. Then final burette reading. Initial burette readings. Volume of acid used. So we are starting with initial at 0.00. I think we have acid. This one will also take us 0.00. Let's see how it goes first. Like we said, you will be told how to carry out the preliminary stage by rinsing the burette with a given acid and rinsing the pipette with a given base. We have already done that. We have equally rinsed this with water we put in it. So we just go straight into titration. Let's reduce this so that our hands can get to it. We fill it. Okay. Remember, always you must remove air bubbles. Okay. Then this one is the base. You give it to you as B. You insert the pipette and titrate. Try to suck it up. Be very careful when you are doing it. So you not release them into the conical flask. This is the conical flask and we are pouring them into it. Make sure you don't blow the last drop, as I told you the other video. If you know what you are doing, titration is not, it shouldn't give you that stress. It's a very interesting part of chemistry practicals. Allow it to drain through by itself. Allow it to drain through by itself. And here we go, still remaining one drop. So you don't need to add down. Then you bring this is your indicator, and this is the dropper. 2 drops, like we said the other time. Good. It's yellow in color, yellowish. So you put a white star. Meanwhile, let's readjust it and start our titration. Always shake or swirl it while it goes on. You can see it has changed to orange, from yellow to orange. You now take the reading, 25.5. First reading, 25.50. Then let's refill it again. Here is our funnel. All we need now is to readjust it to get to 0 mark. Good. Discard this. You can see I'm rinsing with water. Just rinse twice. Make sure everything is out of it. And titrate again. Allow it to drain through. Still draining through. Still draining through. Use the tip to touch the conical flask. Okay, thing is done. Then we now put again 2 drops of indicator. 1, 2. Don't need to be too much in a haste. So you start titrating it again. You don't need to look at the calibration. Don't concentrate on what you are titrating. If you are doing the right thing, you will know just by the color change. You can see it. It has changed again to orange. You can see the orange color. You take the readings now. Take the second reading. 25.1. 25.10. Then let's do the last one. You can see our solution is becoming reduced. Let's see where it can get it to. That is enough. The solution again, we rinse it with water. Twice. Then pipette again. Okay. You still draining through little by little. Let's add indicator and continue our work. 2 drops. First of all, okay, this one didn't get to 35. It didn't get to 0.0, so we started with 10.10. 10.10, 10.00. Can see it has turned to orange again. This is the last one. So now take the readings. It has gone beyond 34.9. So this is now 34.90. So this is the table we have. We now deduct, we subtract. This is 90, this is 4, this is 2, this is 25.10, and this 25.50. Since we are using plus or minus 0.2, we take these two. So our average volume of acid used is 25.10 plus 24.90 over 2. This gives, let's do the calculation, 25.10 plus 24.90 gives 50 over 2 gives you 25.00 cm3. Remember, it must be 2 decimal places. Now let's go for the calculation. We have done this. The equation for the reaction is this. From your result and information provided, calculate the concentration of solution B in mole per dm3. Remember, solution, if you are not told to calculate this, you don't convert. If you convert, it's wasting of time. Therefore, it must get to the time you are going to use this before you convert 2.15 into 50. solution B in mole per dm, but it's in gram per dm cube. First of all, you convert. That is B1. You say 1250 cm cube of B equals 2.15 gram. 1000 cm cube of B equals S. You now say X times 250 cm cube equals 2.15 gram times 1000 cm cube. S will now be 2.15 gram times 1000 cm cube over 250. This one go with the cm cube. Cm go making 4. 2.15 gram times 4. Let's see what it will give us. 2.15 times 4 give you 8.6. 8.6. You don't leave it like this. 8.60 gram per dm cube. So that is that. But we have not finished calculating. Say solution B mole per dm cube. So calculate mole per dm cube. You say molar concentration equals mass concentration over molar mass. Molar mass of what? Sodium hydroxide, because we are dealing with B, NaOH. So it becomes 8.60 over 23 plus 16 plus 1. 8.60 over 40 gives you divide by 40. 8.60 divided by 40 gives you 0.215. 0.215 mole per dm cube. So that's what we have now for Roman figure 1. Roman figure 2, concentration of solution A in mole per dm cube. This one will now help us to calculate solution A, so we can discard this since we already gotten what we want. But remember, this value we should not remove it yet because of the size of the board. So you now say equation. Is now you can write equation for the reaction. They gave you equation before: 2NaOH 2NaOH plus H2S to give you 2NaS plus 2H2O. Mole ratio 2:1. That's base ratio acid. You now say from the relation CAVA over CBVB NA over NB, where CAVA CBVB NA NB. CA we don't know. VA 25.00. CB is what we calculated, 0.215 mole per dm cube. VB 25.00 cm cube. That's the volume of pipette. NA 1 and NB 2. The next thing you say substitute. Substitute CA times VA is 25.00 over CB is 0.215 mole. Sorry, remove the unit. Times 25.00 equals A over B, 1 over 2. So let's erase this so that we have more space. Make CA the surrogate of the formula. Ca times 25.00 times 2 equals 1 times 0.215 times 25.00. So multiply this Ca times 50, 1 times 0.215 times 25.00. Ca to becomes 1 times 0.215 times 25.00 over 50. Let's see what we have. Zero point 215 times 25 give you, divide by 50, give you 0.1075. 0.1075. If you write this one in WAEC, it's not accepted. You mark it wrong. You lose mark for it. You are not wrong, but you lose the mark. 0.108 mole per dmq. 3SF, 3 significant figures. So that's the concentration in mole per dm cube of the acid. Then the last question says molar mass of the acid H2S. That's question 3. To calculate the molar mass, you say molar mass equals mass concentration over molar concentration. Remember, you can also represent it as concentration in gram per dm cube over concentration in mole per dm cube. They are talking about the same thing. Mass concentration is in the question. A is a solution containing 3.70 gram per dm cube. You have 3.70 over molar concentration 0.108. So you have molar mass of the acid H2S, molar mass of acid H2S. You have 3. See, I'm always making it 0 again before I start, so that it doesn't affect this approximation. If you refuse to make your own 0 and you have already approximated, whatever you substitute here with man drum, you see the one I'm carrying is the last answer that I'm carrying. So the mass continue to go on. 3.70 divided by 0.108 give you 34.259. 34.259. 34.259. 34. Opposite to the nearest whole number. You can write 34.2, but usually to the nearest whole number. Gram per mole. So this is how you calculate the molar mass. If you have been told to calculate the value of X, you now say 1 times 2 plus S equals this. X will now be 34 minus 2, making 32, but you are not asked to do that. Thank you very much for watching my video. As I always say, please kindly subscribe and share to your friends. God bless you.